Okay, the second section of 1.6 has to do with temperature scales. There are 3 common temperature scales. The Fahrenheit, which is what we use in America. The Celsius, which is probably the temperature that most of the world uses. This one also says for general scientific use. And then the Kelvin, which we typically use with gases, which we'll get to in Chapter 5, is the SI unit of measurement. It's also called the absolute temperature scale. So this is a comparison of all 3 temperature scales. Kelvin here is on the left, the middle is Celsius, and the right is Fahrenheit. I have water boiling at 212 degrees Fahrenheit and 100 degrees Celsius and 373 K. And I have water freezing at 32 degrees Fahrenheit, 0 degrees Celsius, and 273 K. You'll notice that this has a difference of 273 when I look at Celsius to Kelvin. And also here from Kelvin to Celsius, it's 273. So simply to go from Celsius to Kelvin or back and forth, I either add or subtract 273 degrees. The more complicated part is from Fahrenheit to Celsius. Okay, and the way that I get that is that I'm going to take the difference. So for Fahrenheit, it's 212 degrees minus the 32. So this is the temperature the water freezes. Water boils and water freezes. The difference between these is 180. I can't speak today. And if I look at where water freezes, it is 32. If I look at Celsius, it's 100 for where it boils and 0 where it freezes, so that's a difference of 100. What's the largest common number between these two? So in other words, what can I divide both of these numbers by? And the answer to that is 20. So when I take 180 divided by 20, I get 9. And when I take 100 divided by 20, I get 5. Okay? And that's a factor, and if I divide those two, it's 1.8 degrees. So basically, there's 1.8 degrees Fahrenheit for every 1 degree Celsius. Okay? But this 9 and this 5 is what you're going to see in the formulas for Fahrenheit to Celsius there. Okay? Didn't realize I had all that written out. Okay. So here are the 3 formulas. Okay? So this one tells you that it's given. I give you a formula sheet that has all the formulas for the semester on it. So and those are basically the ones at the end of the chapter for the each chapter. Okay, the key formulas. So this one's given, which is the temperature in Celsius is 5/9 the temperature in Fahrenheit minus 32, and it's very important to realize that these are in parentheses. Now, if I want to solve this for temperature in Fahrenheit, what would I need to do? Okay, well, first thing I need to do is get rid of the fraction in front of this. So I'm going to multiply both sides by 9/5. So I have 9/5 TC. And then because I got rid of that, I can get rid of the parentheses and say TF minus 32. And now, again, still isolating this by itself, what do I want to do? I want to add 32 to both sides. So I end up with 9/5 TC plus 32 is TF. And that is basically what this formula is here. This formula is not given to you because of the fact it can be rearranged from this one. So this formula is not given to you. Okay? And from Celsius to Kelvin, it is given. Basically, it's a 1-to-1. So for 1 degree Celsius is 1 degree Kelvin plus a 273.15. I don't usually even use the 0.15 there. Okay? So, problems of the book, it asks for you to convert from 51 degrees Fahrenheit to degrees C. Okay? So this is the formula that's given to you. Okay? And since temperature in Fahrenheit is given, I'm simply going to plug it in. Okay? So it's 5/9 of 51 minus 32. Okay? So I need to do the subtraction first. So 51 minus 32 gives me 19 degrees. And then the 5/9 of that, so I take 5 divided by 9 times 19, and I get 10.6 degrees C. Okay, that's A. C says take minus 41 degrees Celsius, 2 degrees Fahrenheit. I'm going to again start with the given formula because that's the one that you have. But this time I'm given this one and I'm asked to solve for this one. So I need to do the rearrangement first. Okay, so the same order I just did. I'm going to multiply both sides by 9/5. So I get 9/5 temperature in Celsius is equal to the temperature in Fahrenheit minus 32. And then add the 32 to both sides. And that's the formula. So now all I need to do is put in my temperature in Celsius. So 9/5 of a negative 41 plus the 32 is minus 70. So when I do 9 times the negative 41 divided by 5, I get the negative 73.8 and then add 32 to that. So I get a negative 41.8. The interesting thing is that the degrees Celsius and degrees Kelvin do cross at one point. So that, and we're very close to that point, that minus 40 degrees Celsius is equal to and minus 40 degrees Fahrenheit. That's the only point that the two temperature scales match up. Okay? And so, just to go back real quick. So I basically multiply by 9/5 on this side times 9/5 on that side, get this formula. I add then 32 to both sides and get this formula. So that's where that all came from.